in theory of computation, you will have to prove many things, like, if the problem is solvable or not solvable. One thing is, you should be able to find out whether a statement holds, or if it holds, what are the other rationalities connected to it, and all other stuff. Now, for that proving, there are many kinds of proving techniques which are adopted in mathematics, but we will be mainly seeing about two kinds of proof techniques. One is proof by induction, and the second one is proof by contradiction. Now, first we will see something called proof by induction. Now, proof by induction, you will have a statement. Let's simply say I do have a statement which says, let's say the average of n numbers. Okay, I say the average of n numbers is let's say average of n numbers is n1 plus n2 plus etc. up till, let's say, of m numbers. So I write plus nm divided by m. Okay, this is my formula for finding the average of m numbers. Okay, now I have to prove whether this particular statement holds or not. Okay, so I do have a statement which tells the average of m numbers is n1, n2, n3, etc. up till nm, the sum of all of that divided by m. Now, to prove that, to prove whether this particular statement is true or not, okay, I have to prove whether this is true or this is false. The first method which we can use is something called proof by induction. Now, in proof by induction, what you do is you will first prove whether that statement holds for a number called 0. That is the step number 1. You check whether the statement holds for a number called 0. After that, what you do is you check whether the proof holds for a number called n, or let's say k. We'll go for a foreign number. You check whether the proof, the same proof, it holds for a number called k. After that, third step, what you do is you check whether the same thing, it holds for something called k plus 1. Okay, so the first step is you check whether it holds for a number called 0. The next is you check whether it holds for a number called k. And the third step is you check whether it holds for a number called k plus 1. If all these three are true, you say that the given statement is true. So I'll repeat once again. In proof by induction, we want to make a claim. Okay, we want to make a claim that the average of n numbers is n1, etc., the sum divided by m. Okay, so we know that, it holds for m. You very much know that it holds for m, but you have to prove it. Yeah, it is actually true. So what you do is you check for all the positive numbers. You check for all the positive numbers. You start with 0. You start with 0. You go on to k. You go on to k plus 1. If all these hold true, I say my particular statement is true. So to prove whether something holds by proof of induction, you will be having 4 steps. Okay, you will be having 4 steps. The first step, or the starting point, you call it the basis. You call it the basis. This is where you prove it for a number called 0. The starting point for the induction is called the basis, and then you check for the number called 0. The second step is you do something called induction hypothesis. Now, induction hypothesis is where you check for the nth number, or let's say the previous example, I was telling you about a number called k or n, whatever. Okay, you check for the last number. You check whether it holds for the last number. That step is called induction hypothesis, where you check for the nth number or the kth number or the jth number, give any naming convention. Anyway, the last number. The third step is the most important thing, the induction step. The induction step is actually where you do the proof by induction. Here, what you do is you check whether that argument holds for k plus 1, or let's say n plus 1, whichever naming convention you're using. You check whether it holds for k plus 1 or n plus 1. And if it holds for k plus 1, it means your argument is correct. And then you come to the conclusion. So very simple. Proof by induction, you say that an argument holds perfect or valid if it holds for 0, if it holds for a number called k, and it even holds for a number called k plus 1. So if all these three steps you are able to make valid claims, you say that the given question is proved. So let's do a small problem. Have this problem down. Proof by mathematical induction. When I write mathematical induction, it is proof by induction. Okay. Proof by mathematical induction that sum of n numbers is n into n plus 1 by 2. So this is my question. Prove by mathematical induction that sum of n numbers, okay, I is equal to 1 to n, sum of I is equal to n into n plus 1 by 2. As I told you earlier, I will be having 4 steps. Step number 1, which is my basis, where I do have to do things for n is equal to 0. Then I have my second step, the induction hypothesis, where I have to do for n is equal to k. The third step is my most important thing, the induction step, where I have to prove things for n is equal to k plus 1. And then I have the conclusion. So always have in your mind that when you do a proof by induction, write down the steps. Okay, step 1 basis, step 2 induction hypothesis, step 3 the induction step, and step 4 the conclusion. So let us do one by one. Okay, so the first thing what you have to do is you have to prove this for n is equal to 0. Okay, so let's prove it for n is equal to 0. Okay, so n is equal to 0 or I is equal to 0. I'll just simply write here n is equal to 0. Okay, so which means, I'll substitute all of this as 0, 0 into 0 plus 1 by 2, which means, it is a 0. Okay, you think about 0 numbers, the sum of 0 numbers is 0. Anyway, that is proved. Okay, so my basis for n is equal to 0, that is already there. You need not prove it actually. It is a step where, you already know that it is 0. Now, the same way, let me write my second step. Okay, my second step is I will have to do it for n is equal to k. Okay, so I'll write for up till k numbers. Up till k numbers, what is it? K into k plus 1. I need not prove it. These are my steps. These are my steps. This is my step number 1. And this is my step number 2. My step number 1 and my step number 2, I directly get it from the given statement. I do have a statement over here which tells me this. My step number 1 and step number 2, I need not prove it. It is already there. It is already there. So I just simply write it down. Yeah, okay. Now, this is where comes the most important part. You have to do it for k plus 1. Okay. So I'll just copy it down. I'll copy this down. That looks better. Okay. It is up till k plus 1. Okay, earlier I did for 0. Now I'm doing up till k plus 1. So, it is not n plus 1. Instead, I have k plus 1. And it is not again n. It is over here k plus 1. Okay, now if you look, the sum of k plus 1 numbers, the sum of k plus 1 numbers is nothing but the, I'll write it down over here, the sum of k plus 1 numbers is equal to sum of k numbers plus the k plus 1th number. Okay, hope you're able to understand it. The sum of k plus 1 numbers is the sum of k numbers plus the k plus 1th number. Okay, like very simple, the sum of 5 numbers is equal to nothing but sum of first 5 numbers. Imagine the sum of first 5 numbers. It is nothing but the sum of the first 4 numbers plus 5. That's it. Very simple. Okay. So keeping that logic in mind, I can say this is nothing but, just copy this down over here. Okay. Having that logic in mind, what I'll do is, this is nothing but the sum of k numbers plus the k plus 1th number. Okay, I can even just do a bit of mischief over here. I can simply write k plus 2. Okay, I just k plus 1 is equal to k plus 2. Now I'll go on simplifying this. I'll have to simplify this. Okay, very simple. I have to find out at the end of the day, LHS is equal to RHS. If LHS is equal to RHS, it means it is proved. Okay, so now let's find out. Okay, I do have a k plus 1 over here. And from my earlier formulas, I know what is this. This portion I already know. What is this portion? This portion is already this k into k plus 1 by 2. Okay, so I just replace it. I'll take the whole thing. I'll put it down. Yeah. And I am replacing because, I know it. I know that this portion is k into k plus 1 by 2. Okay, I just simply replaced it. Okay, now look here. Everything has a denominator of 2. I'll even make this, I'll give this also a denominator by 2. Okay, I'll give this also denominator by 2. Just copy this down again. I'll write steps so simple so that you people are able to understand. Okay, now, I'll just make everything, I'll give everything a common denominator. I'll give a common denominator of 2. Just write a fraction over here. Okay, k plus 1 is equivalent to 2 into k plus 1 divided by 2 into k plus 1. Okay, so I'll just simply write over here plus 2 into k plus 1. Okay, it's a small k, yeah, divided by 2. Okay, so I replaced this particular term by simply giving a denominator on top of 2 and then a numerator, denominator and a numerator of 2. 2 and 2 will actually cancel, which is equivalent to k plus 1. Isn't it? Okay, so now everything, they have a common denominator by 2. Now what can I do? I'll just cut off all those common denominators. It is equivalent to not having a denominator. So I can write k into k plus 1. It is small k, right? K into k plus 1 plus 2 into k plus 1 is equal to k plus 1 into k plus 2. Okay, I just removed off the common denominator. It's cost, yeah, I just cancelled off the whole thing. So, I just wrote my numerator part, k into k plus 1 plus 2 k plus 1 is equal to k plus 1 into k plus 2. Now look here, k plus 1 is common over here, isn't it? K plus 1 is common over here. Hope you remember your factorization. So I just take out the common term over here, k plus 1, small k. Okay, k plus 1 is common. Then what do I have remaining? K plus 2 is equal to k plus 1 into k plus 2. Yeah. Wow, look, LHS is equal to RHS. LHS is equal to RHS. I simply did an algebraic simplification and I got LHS is equal to RHS. Thus, what happened? Thus proved. What did you prove? You proved that this holds true for all numbers. You think of any natural number, this particular statement will be true. This is how you do proof by mathematical induction. I will go once again. Okay, so you have got to prove this. Sum of natural numbers is equal to n into n plus 1 by 2. So first I write my statement, n is equal to 0. Yeah, I get a 0, perfect. Okay, then I do n is equal to k. That is my next step, the induction hypothesis. So, wherever I have an n, I simply replaced it with k equal to k into k plus 1 by 2. Now the next step is the induction step where I have to prove it for k plus 1. So wherever I have my n, I simply put k plus 1, k plus 1, k plus 1. Yeah, that's it. And now I do my mathematical simplification. Okay, so as I told you, the sum of k plus 1 numbers is nothing but the sum of k numbers plus the k plus 1th number. Okay, so I wrote the kth number, sum of up till the kth numbers, up till the k plus 1th number. And then I simply went on to write the simplified thing, k plus 1 plus 1, k plus 2. And then what I did is, I already know the sum of k numbers from step number 2, isn't it? From step number 2, from this particular step, I already know that sum of k numbers is equivalent to k into k plus 1 by 2. That's it. So I gave a common denominator for everything. I did a mathematical simplification. At the end of the day, I got LHS is equal to RHS. Okay. The moment I get LHS is equal to RHS, things have been proved. So the next example we will see is proof by induction. The sum of squares is equal to n into n plus 1 into 2n plus 1 divided by 6. The sum of squares. Okay. So we'll follow the same method. You will be having 4 steps. One is the basis. For n is equal to 0. Okay. So, I'll just copy this down. I'm lazy in typing, that is why. For n is equal to 0. N is equal to 0 or k is equal to 0 or whatever. Which means, 0 into 0 plus 1, 2 into 0 plus 1, which obviously will be 0. Okay, so that's it. That has been written. So that's it. N is equal to 0. Now we'll do n is equal to k plus 1. I'll just copy the same thing over here. Not k plus 1, for k. Okay, n is equal to k, which is nothing but k. Wherever you have an n, put in a k. 2 into k plus 1. So that is also done. Okay, my first step is done. N is equal to 0. My second step is also done. Okay, Now I've got to go to my most important step. N is equal to k plus 1. Okay, so n is equal to, where n is equal to k plus 1. So wherever you have an n, replace it with k plus 1. Replace it with k plus 1. So I have an n over here. So I'll write k plus 1, k plus 1. And then I even have an n over here, 2n. So I'll write over here k plus 1. Yeah, that's it. So, I'll just copy this over here. So, I'll follow the same logic. Sum of k plus 1 numbers. Okay. Sum of k plus 1 numbers is equal to sum of k numbers plus k plus 1 the whole square. Okay. Plus the square of the k plus 1th number. The same logic. Okay. Sum of, not sum of, k plus sum of squares, isn't it? Sum of squares of k plus 1 numbers is equal to sum of square of k numbers plus the square of the k plus 1th number. Simple logic. I'll go once again. Sum of the squares of the k plus 1 numbers is equal to sum of the squares of k numbers plus the k plus 1th number square. Okay. Which is nothing but, I'll just copy this. Okay. Which is sum of the k numbers plus the k plus 1th square. I'll just give a superscript. So, it is nothing but sum of the square of k numbers plus the k plus 1th squares is equal to my RHS. Look here, when you go up, you already know what is the sum of the first k number square. I'll just copy this and I'll put it over here. I'm just replacing it. Okay, I'll just replace this over here. Okay, plus k plus 1 squares, I'll just do a bit of mischief all here. K plus 1 plus 1, this is k plus 2. 2k plus 1 is nothing but 2k plus 2 plus 1. Okay, so, I'll just copy this whole thing again. I'll put it down. Okay, I'm now going to do a simplification. Okay, this is nothing but 2k plus 3. 2k plus 3. Okay, this k plus 1 square, as you know, it is k plus 1 into k plus 1. Now look here, the first term and the third term, they do have a denominator of 6, which means, I will even have to give this a denominator of 6 so that there is a commonality between all the terms. So, I'll just put a 6 over here and then a 6 as the denominator and the numerator. I'll just put a fraction. Okay, I'll just make this a fraction. Okay, which means this is 6 by 6. And then, I'll just Okay, it's k plus 1 square. For easiness, what I did is, I just did it k plus 1 into k plus 1, k plus 1 into k plus 1. Okay, so now, all the denominators are 6, which means, the whole thing, it goes cancelled away. Now, I'll just write all my numerators, k into k plus 1, k into k plus 1 into 2k plus 1 plus 6 into k plus 1 into k plus 1 is equal to my RHS k plus 1 into k plus 2 into 2k plus 3. Okay, I just did away with my denominator. I've just copied out everything, k into k plus 1 into 2k plus 1 and so on. Okay, so now what I can do is I can now look here, k plus 1 is a common term over here, isn't it? I have two terms actually over here. One is this term and the other is this term, out of which k plus 1 is common in both. Okay, so just take the common term outside, k plus 1 into 2k into 2k plus 1 plus 6 into k plus 1 is equal to, here I'm not doing any change, let it be as it is. Okay, so all what I've done here is I have a common term k plus 1. These two terms, I do have a k plus 1 over here. I even have a k plus 1 over here. I just took it outside. So when I took it outside, the remaining thing is k into 2k plus 1. I wrote it down over here, k into 2k plus 1 plus k into 6 plus 1. Okay, so now I'll just copy the same thing down over here. I need to do a simplification, an algebraic simplification. Okay, so this I can write it as, okay, I'll do a simplification over here. This particular term, I'll do a simplification. 2k into k is 2k square, isn't it? 2k square okay, 2k square plus 2k plus not 2k, 2k square plus k, isn't it? There's no 2 over there, plus 6k plus 6. Okay, so I've just done a simplification of that. 2k square plus k. Okay, now you will have to do a factorization of this. But by doing all this, I need to try getting something equivalent to my RHS. Okay, so I'll just do it below over here. I hope you remember your high school mathematics. So this I can write it as plus 7k. Okay, isn't it? K plus is equal to plus 7k. Okay. Hope you remember your a plus b, a in the sum is, okay, the sum of terms is, okay, sum is equal to 7. The product is equal to what? 6 2s are 12, isn't it? Therefore, the terms are what? Terms are, if a plus b is equal to 7 and a into b is 4, 3. Terms are 4, 3. Okay, so I write over here. Instead of 7K, I can write 4K plus 4K plus 3K, isn't it? Because, mathematical simplification, I got it. If the sum is equal to 7 and the product is equal to 12, the terms will be 4 and 3. 4 plus 3 is equal to 7. 4 into 3 is 12. Your basic mathematics. Okay. Now I can take the common term outside. So I can write 2K. Okay. Take the first two terms. What is common over here? It is 2K. Then what do I have remaining? I have remaining x plus 2. Okay. Next two terms, what is common? 2 is common, isn't it? 2 is common. And then I have a k plus 2 inside. So this is equivalent to k plus 2 into 2k plus 2. K plus 2 plus not 2, 3, isn't it? 3 is common. 3k plus 6. Yeah. So 2k plus 3. Yeah. Okay. So this is my final term. Okay. So I'll go up. And then instead of 2k square, etc., I can replace my k plus 2 into 2k plus 3. Is equal to okay, look here, k plus 1, k plus 2, 2k plus 3, which means my LHS is equal to my RHS. Okay, these are actually my working stuff. These are actually working stuff. Let's put it in green. Okay, so anyway, I did prove that my LHS is equal to my RHS. Thus proved. Because as long as my LHS is equal to RHS, this is proved. What did I prove? I proved by induction that the sum of the square of natural numbers is this particular formula, n into n plus 1 by 2n plus 1. How did I prove it? We know it holds for 0. We already know it holds for k. I checked out whether it holds for k plus 1. I tried proving mathematically, and then, yeah, I was able to get my LHS is equal to my RHS. I just copy this down. These are things actually you don't want. Not like you don't want. These are the working stuff. Okay. So thus I was able to prove that this is the formula for sum of the square of n numbers.